Okay, so let's have a look. Results from maths exam normally distributed with mean 60, standard deviation of 8. So, first things first, mean 60, 68, 52, that'll do us, I think. Find the proportion of students who pass, when the pass mark is 40%. We're saying there we really want to know the probability that the result was greater than equal to 40, yeah? So let's just go normal CDF. It's a 68 and we want 40 to infinity. That's going to give me 0.9938. All right, part B, scored above 80%. Well, it's a similar thing. Probability that X is greater than 80 or 0.8. Normal CDF. We've got, if you like, from it's a 60, using the format of the calculator, we'll write it as it's a lower bound, upper bound, so it's above 80%, so it's 80 to infinity for a 68 distribution, and that gives me 0.0062. Okay, so question 2, if a student is chosen at random, find the probability she scored a score above 70 given she passed. So we need the score of greater than 70 given she was greater than 40, because the pass mark was 40. So using our conditional rule, that's the probability that X is greater than 70 and X is greater than 40 over probability that X is greater than 40. Bit tight for a room here, isn't it? So a score that's got to be greater than 70 and greater than 40 is the same as the score that's greater than 70 over the probability of a score that is greater than 40. So use our normal CDF information there, we should get a final answer. 0.1063. Okay, finally, if the top 10% of students are awarded a prize, what score requires? So what we're saying here is we want the score up here, where that value there is 10%. So that means all of that stuff has to be 90%. So because our inverse norm works with an area less than, I want the value that gives me 90% of the data for a 68 distribution, which is equal to or of 70 point, I better put 2524 to 4 decimal places. So anyone that basically got a mark above 70 was in the top 10%. All right, how does that sound? Well, 68 is one standard deviation above, so that seems reasonable, doesn't it? All right, 13. The height of an adult giraffe is normally distributed. 5% of giraffes are more than 8 meters tall, but only 10% are less than 6 meters tall. Find the mean and standard deviation. Okay, so we've got 2 bits of information here, isn't it? The value of 8. Okay, so what does that mean? It means the probability that X is greater than 8 is equal to 5%. And the probability that X is greater than 10 is equal to, less than 10 is 0.1. So there's our 2 bits of information there. So I don't know the mean and standard deviation, do I? But I do know what I need to do here is I need to work out some corresponding Z values, because I know that Z is equal to X minus mu on sigma. All right. So if I can work out the Z value, so if I can work out the corresponding Z value here, the probability that Z is greater than 8, greater to some value B is equal to 0.05, and work out the probability that the Z value being less than C equal to 0.1, I can use this formula here. So using my standard normal curve, this gives me a Z value equal to, and that gives me a Z value equal to. So the chances of less than some, so what we're going to type in, we're going to put inverse norm 0.1 of 0.1 gives a Z value of negative 1.28. I'll put 282. And for the second one here, B, because my inverse norm works with less than, I'm going to put inverse norm 0.9501, and that gives me a Z value of 1.645, say. All right. So in here, I've got the Z values. I now need, and I've got the X values. I need to work out mu and sigma. Okay. So equation 1 will give me a Z value of 1.645 times sigma equals the X value, which was 8 minus mu, and equation 2, a Z value of negative 1.282 times sigma equals a score of 10 minus, not 10 at all, 6 minus mu. So if we solve that on our CAS, we'll end up with a mu equals, what did it give me? Mu is equal to 6.88 and sigma equal to 0.68, which kind of looks about right. So 0.7, if I add 2 standard deviations to 6.8, that takes me up to 7.5, a little bit over 8, which, 2 standard deviations above would leave me 2.5% above 8. So it seems a reasonable sort of mark. Okay. Final one. Bolts are produced on a particular machine having a diameter which is normally distributed with mean 10 and standard deviation 0.2. Find the proportion of bolts that have a diameter of more than 10.5. So it's, again, quick sketch. And a mean 10, 0.2, so 10.2, 10.4. So we can see straight away 10.5 is well above 2.5 standard deviation, so we're expecting a small value. So normal CDF, let's get the order right. What do we put in first? We'll put in our 10.5 to infinity, and it's distributed with a 10.2, and that is equal to 0.0062. Doesn't really say how many decimal places, so I'll leave it at 62. Probability is between 9.9 and 10.1, so 9.9 is down here somewhere. So we'll just go for normal CDF 9.9, 10.1 on a 10.2 distribution, and that gives me 0.3829. Right, a bolt is accepted and hence sold if its diameter is between those values. Out of 10 bolts produced by the machine, find the probability that all are accepted. Okay, now this kind of question pops up a bit. All of a sudden now, in there, I have 10 trials. So this becomes actually a binomial distribution where I've got 10 trials, and the probability of getting a bolt between 9.9 and 10.1, I've just worked out previously, is 0.3829. So it becomes binomial now. So we can say, if you like, the bolts are distributed binomially with 10 trials and a probability of success of 0.3829. All are accepted. So the probability that x is equal to 10 is given by 10 C10 0.3829 to the power of 10. 1 minus that, which we don't need, to the power of 0, which is the same as my binom PDF. What do we want? 10 trials, 0.3829, and 10 successes, which is equal to to 4 decimal 0.000068. So it's unlikely all 10 are going to be accepted. But the probability of at least half means x is greater than or equal to 5. So I binom CDF 10.3829, at least half is 5 to 10, and that gives me 0.32469, so 7. All right. So it's just that being able to read a problem and go, okay, this is all normal. So in reality, it's sort of all normal through here, even the question, and then all of a sudden, in through here, we swing into binomial. All right. So just keep track of that. And the giveaway, 10 trials. And so that's fairly typical. Okay.